In this video, I will show you how you can use VGG to understand deep convolutional networks. VGG stands for Visual Geometry Group. This is University of Oxford. It introduced in 2014, and it is famous for its simplicity and depth. Why is VGG important? First of all, it demonstrated that depth improves performance. Used very small 3x3 convolution filters, became a foundation for later CNNs, RESTnet, and Inception. The architecture of VGG, first of all, we have the input size, 224 by 224. This is the width and the height of the image, by 3, which is the channel, RGB. Stack of convolution layers, 3x3 filters, ReLU activation, max pooling layers, and ends with fully connected layers. There are some types of VGG like VGG16 and VGG19. In this video, I will demonstrate how you can use VGG16 architecture, which contains of 16 weight layers, 13 convolution layers, and 3 fully connected layers. This is the code. Here, the path of the image that you want the model to predict what it is, and then to convert the image into array so the model can deal with it. Then we convert it to 3D tensor. This is the pre-process for VGG16. All of these methods are imported from keras.applications and keras.preprocessing.image. And then we make the prediction using the image array. Then we decode the prediction. And if you display the image, you will find that the prediction is about, with accuracy, 52%. And it is a bullfrog. So when you should use a VGG? For learning CNN basics and feature extraction. It is not suitable for mobile apps or large-scale production systems.